Hello, my dear students. Let me welcome you all to today's session. Today we are going to solve a few questions from the topic geometry and mensuration. I have set this session in such a way that you feel as if you are playing a game. Okay, so let me explain. It's something like a cat and a mouse chase. Okay, so how it is planned. The main objective, I should say, it's to help you to understand how to read a question and then perform the problem solving in a time bound manner. Okay, so you must be ready with all the concepts before you begin this session. So that's very important. All right. Now, what are the rules? Altogether, we have got 11 questions to be discussed, and that's what I'm going to do in this video module. One question will be presented in front of you at a given point of time. Okay? There will be a timer that is going to be running on the bottom right hand side of the screen. You're going to see it soon. I have set the timer. So all you need to do is you must try to answer the question before it shows time out. Okay? So that's why I said it's going to be something like a cat and a mouse chase. Now, time out ho gaya kya? No need to worry. You may pause the video and continue your attempt. You take your time to solve the question and then make sure you watch my explanations and my commentaries as well. Okay, but the effort you must put, you must try your best to answer the questions before it shows timeout because you already have the concepts ready. So it's just a matter of how quickly you are able to recall the same and then apply them and then fine tune your test taking skills. All right. So are you all ready? Always be positive. Okay. Be persistent in your attempts and in your efforts. And then experience the improvement that's going to happen with reference to your problem solving skills. Always remember, Rome was not built in a day. So, are you all ready? Shall we begin? Here we go. The first question I'm going to present. This is the first question. On the right hand side of the screen, you can see there's a blue dot, right? That's the timer. So let's begin the session. Your time starts now. Keep attempting. Okay, keep a look at the timer. Ready? All right, it's time out. So let me give you the explanation for this question. Read the question. Each side of a triangle, it's 8 centimeters less than the sum of the other two sides. You are asked to find the area of the triangle. When you read the first sentence, if you understood that the triangle I am referring to, it's going to be an equilateral triangle. If you get that intuition, understand, that's really great. I appreciate that. Now, If you have a doubt, how does it actually work? No problem, I shall explain. I'm considering a random triangle here. Okay, I'm not saying that it's an equilateral triangle. I'm just considering a random triangle here. Let the sides, let it be A, let it be B, and let it be C. Okay, the three sides. It's given each side of the triangle, it is 8 centimeter less than the sum of the other two sides, right? So I can say A, it is equal to B plus C minus 8. 8 less than the sum of the other two sides. In the same manner, I can say the second side here, B, that is equal to A plus C minus 8. In the same way, I can consider the third side here, C, that is equal to A plus B minus 8. Okay. Now, I am going to add these three, the three conditions that I have presented here. I'm just going to add them. So I get A plus B plus C, that is equal to 2 times A plus B plus C minus 24. Got it? Because I can see that A happens here twice, B, it happens here twice, and C also, it happens here twice. So the right hand side, when you look at it, it's 2 times A plus B plus C minus 24. 8 3s are 24. So that gives me the result A plus B plus C. It is equal to 24. Got it? Now, from this, can I not say, for example, B plus C, can I not say it is equal to 24 minus A? Now, I want you to consider this first case here. It says A is equal to B plus C minus 8, right? So instead of B plus C, can I not substitute 24 minus A? So that first condition, it's going to become something like A, it is equal to, instead of B plus C, you put 24 minus A, minus 8 it will come. Yes or no? I just replace that B plus C with 24 minus A. So A, it is equal to 24 minus A minus 8. It comes like that. Okay. Now, this results in taking that minus A to the left-hand side. I can see that it becomes 2A. It is equal to 24 minus 8. I can say this will come here as 16. Okay. 24 minus A, minus 8 when you do. Minus A goes to the left-hand side. 2A, it is equal to 24 minus 8. That is equal to 16. And that gets me A. It is equal to 8. Got the point? Now I can repeat the same for the second condition here and also the third condition here. In every instance, I can see that I will be getting the measure of the sides. It will be equal to 8. This is equal to 8. This is equal to 8. And this also will be equal to 8. Because you can see that it's following that pattern, A equal to B plus C minus 8. It's symmetric all over. I can see that it maintains the same condition there. So A equal to B equal to C equal to 8. Got it? So that means the triangle under consideration, it is an equilateral triangle. You are asked to find the area of this triangle. I know the area now, it will be root 3 by 4 A square. That is 8 into 8. And how much this comes to? I can say my answer, this will come here as 16 root 3. It's in centimeters, right? So centimeter square. So for the first question, the correct answer, it is 16 root 3 centimeters square. I hope the explanation, it's clear to you. We have taken care of the first question here. Okay. Now, I want you to attempt the second question. So the same way, you see the timer is going to run. So make sure that you answer the question before it shows timeout. So let's go to the next question now. The second question it is given here. Your time starts now. All right, time out. So let's quickly recall the circle that is mentioned here. It has got a name. What is this? We call it as the incircle, right? So find the area of the circle which is inscribed in a triangle whose sides are 10, 13, and 7. You can as such answer this question without drawing any diagram. You need not waste your time attempting to draw a diagram here. But you need to recall, as far as an incircle it is concerned, the in radius, if you want to find out, remember the formula, area of the triangle that is equal to the in radius into the semi perimeter. Got it? So that's what we have to always consider here. So if I am considering a triangle here, a random triangle I'm just considering for your understanding. And imagine that I'm drawing a circle, okay, that looks somewhat like this. Okay, it touches the three edges in this way. This circle, it is the incircle. The circle, it is inscribed inside the triangle. This circle has got a radius, that is this in radius. It will be touching the three sides like what you see here. Okay, so that's the in radius I'm talking about. Area of the triangle, please be aware, that is equal to the in radius into the semi perimeter. So you have got two tasks here. Task number one, finding what is the semi perimeter. So you know that 10 plus 13 plus 70 whole divided by 2. That gives you the semi perimeter. You know that 17 plus 13, it's equal to 30 plus 10, 40 by 2. That is equal to 20. So I could get the value for the semi perimeter here, that is equal to 20. You are asked to find the area of the circle, for which you need to know the radius, right? So let me consider the radius here, that's unknown. Now, the missing link it is to find the area of the triangle. So when I was just going through 10, 13, 17, I don't see that any relationship it is there like a right angle triangle or anything like that. So I have to use the hero's formula to find the area of the triangle. That will be equal to root of semi-perimeter S into S minus A into S minus B into S minus C. You got it? So that is going to give you the area of this given triangle. And in the question, it is given that this area, it is equal to R into S. You got my point? So root of 20 into, I will just write this once again. This is nothing but square root of 20 into 20 minus 10, you know, it is 10. 20 minus 13, it is 7. 20 minus 17, you know, that is equal to 3. So root of 20 into 10 into 7 into 3. This value, it is equal to R into 20. So you just square this left-hand side and right-hand side, and then you get R square. So solving that, you can get the value for that R. And once you know R, you can easily find what is going to be the area, right? So from this, I can see that R square, when you do the calculation, I can see that when I take the square here, R square, that is coming here as 21 upon 2. Okay, that's what you will get, R square, when you square it, 21 upon 2. Now, the area of this circle, it is pi r square. Therefore, pi r square, it will come here as 22 by 7. That's for pi r square. It is 21 upon 2. So that gets me 7. It will go in 21 3 times. 2 here 11 times. 11 into 3 it comes. So my final answer for this question, that will be equal to 33 square units. Be careful here. They are not mentioned whether the side it is in centimeters or meters or what. So you will just say 33 square units. Okay, that will be my final answer. So how does the practice go? I hope you are able to follow the explanations, right? Fine. So make sure that you are trying to answer the question within the stipulated time, and then make sure that all your efforts that you are making here, it's to solve the questions correctly within the available time. Okay, let's go to the next question. Your time starts now. Okay, keep a watchful eye on the timer. And here we go, time over. So let me quickly explain this question. Okay, so what does it say here? In the question, it is given AD, it is the angle bisector of angle BAC in a triangle ABC, where BC is 15, AC it is 18, and AB it is equal to 12 centimeters. Find the ratio of the areas of triangles ABD and ACD. That's what it is given. So for answering this question, definitely, you need to draw the triangle. So let me quickly do that. It's BC, AC, AB. They are telling you it is 12, 15, 18, like that they have told you. Okay. So I am considering it somewhat like this. Okay. AB, and let me consider this is 18, the longest AC. Okay. And then I'm considering this BC like this. Okay. So I'm just drawing it this way. Just have a look at this. This is A. Let me say that this is B, and let me say that this is C. AB 12, BC it is 15, and I'm considering AC, this is 18, the three measurements. It's given that AD, it is the angle bisector of angle BAC in the triangle. So look at this. This is that angle BAC. Just see. So angle bisector means from A, I'm going to draw a straight segment like what you see here. Okay. And please note, it's going to touch this BC at a point here, and let me represent it using the letter that is D. Okay, so have a look here, AD. So I'm now considering AD, it is that angle bisector of angle BAC. BAC, I can see that it's getting divided into two equal parts, alpha, alpha, you can see. So that's why I'm calling that as the AD, that is the angle bisector of angle BAC in that given triangle ABC. And the sides I have considered, right? Now, please note, as far as this triangle ABC it is concerned, you can see AB upon AC. If I am going to take it, please observe AB by AC. If I am going to take it, understand in that same ratio, it is going to be BD and CD. Got it? AB by AC will be same as BD by CD. That result you have to keep in mind. So I can thus see that here BD by CD that will be nothing but 12 upon 18. Cancelling it with 6, I know it is 2 upon 3. Got it? So I have that BD by CD, that ratio, it is 2 upon 3. Now, again, some more observations you have to make here. I can see that here, this base BC, and you can consider, look at the base BC, okay, and look at here, this particular height of this given triangle. Want you to observe it very closely. This is the height of the triangle. Okay, so I can see that these two triangles that has been mentioned here. Observe very closely. Triangle ABD and ACD. Look at ABD. This is the triangle 1T1. And look at the triangle ACD. That is the triangle T2. Look at those two triangles. Don't you see that these two triangles, they have got the same height? Don't you see that? The height, it is the same. So if the heights are equal, then you know that the areas, it is going to be proportional to the base of the triangle. Because area of a triangle is half BH, right? So if the height it is the same, then understand the area, when you are going to consider, it is going to be in proportion to the length of the base. Got it? So the more the base, the more the area. Lesser the base, lesser will be the area. So can I not say that here the ratio of the areas of the triangle ABD and ACD, what you observe there, that ratio of the areas, it will also be 2:3, right? So I can consider now this answer for my question, it will be equal to 2:3. Okay, if you have a doubt over there, then I will just show it to you, prove it to you. This is that height h it comes. The ratio I told you it is 2:3, right? So this 50, sorry, the third side, BC, it is given as 15. That 15, I am going to divide it in the ratio 2:3. So that gets me BD, it is equal to 15 into 2 by 5. What is that value? This value will come here as 15 into 2 by 5. So 6, this will come, and this will come as 9. So area of this triangle ABD, it will be half 6 into height. And you can say area of triangle ACD, that will be half 9 into height, half BH. You can see that the ratio, it will come as 6 upon 9. That is as good as 2 upon 3. It comes that way only. But you can skip these steps, provided you are able to quickly recall when the height is the same, then the area of the triangle, it will be in proportion to the base. The more the base, the more the area. Lesser the base, the less will be the area. Okay. In the same way, when the base remains the same, you can see that area of the triangle, it will be proportion to the height. The more the height, the more the area. Lesser the height, lesser will be the area, but provided the base, it remains the same. Okay. So you can use these results interchangeably for solving the questions. Our answer for this question, it is 2:3. I hope this explanation is loud and clear to everyone. Now let's move on to the next question. Meanwhile, any doubts you have with reference to the questions that has been discussed, please make sure that you are interacting with me and asking for clarifications. Let's go to the next one, the fourth one. Your time starts now. All right. Time is almost over. Fine. So Let's look at this question. In triangle PQR, a line is drawn parallel to QR and cuts P, Q, and PR at S and T respectively. So let's do that portion first. Okay. So I am considering a random triangle here. So just observe here. It's a random triangle. Okay. I don't know whether it's equilateral or isosceles or anything. That's why I'm calling it as a random triangle. Okay. So I am considering that this is P. Okay. Let me consider that this is Q, and let me consider that this is R. So in triangle PQR, it is given a line. It is drawn parallel to QR. So we have this QR here, right? So I'm considering parallel to QR. Okay. I'm drawing a line. So it said that it cuts this PQ and PR at 2 points S and T respectively. So please have a look at this. I'm considering that this is the line. So this is the point S, what I can consider. And let me consider that this is the point that is T. Got it? So QR and ST, please understand that they are parallel to each other, right? So I have considered the triangle PQR. As you can see, I'm drawing a line which is parallel to QR. It is cutting P and Q at S and T respectively. Up to that point, I have taken care. Fine. Now it is given QS, it is equal to 10. Okay. So I use a different color here. This is that QS, it is equal to 10. PQ, it is equal to 25. So the full length PQ, it is 25, wherein QS, it is equal to 10. So can you not say that PS, it has to be 15? So PS is 15, SQ, it is 10. So 15 plus 10, I can see that PQ, it is equal to 15 plus 10, 25, it comes. Now find the area of the triangle PST, the small one. If the area of the quadrilateral SQRT, it is 480 square units. Okay, so one thing what I can understand here is using that basic proportionality theorem, if I'm considering, you see that PS is to SQ when you are considering, this is 15 is to 10, right? When you are considering. So I can just go for, even I can go for similarity, the similarity of the triangles as well. So just see, if I say that this angle, if it is alpha, automatically this angle will also be alpha. Corresponding angles, parallel lines. In the same manner, if I consider that this is beta and this also will be beta. So two angles you can consider. And I can see that this is theta. If I consider this P, it is theta. And look at two triangles. Triangle PST, it will be similar to triangle PQR. Yes or no? Because angle P is angle P. You can see that PST, it is same as PQR. Angle S and angle Q, they are one and the same. In the same way, angle T and angle R, they are one and the same. So using that AA similarity concept, can I not say that triangle PST and triangle PQR, they are similar? So that helps me to say the ratio of the sides of the small triangle is to that of that big triangle. The ratio of the sides, I would rather consider PS divided by PQ if I take. I know that that will come here as 15 divided by 15 plus 10, that is coming here as 25. Yes or no? That is simplifying it, cancelling it with 3. I can see that this will come as 3 upon 5. Don't you agree with me? So the ratio of the sides, when you're going to consider for the triangle PST and the triangle PQR, the ratio of the sides, it will come as 3 is to 5. So I can thus conclude that the ratio of areas of triangle PST and triangle PQR. You know, the ratio of the areas, it is going to be the duplicate ratio of that 3:5, and that is nothing but 9:25 it will come. Got it? So I can just see, using the proportionality concept, I can see that if this area, it is 9, that is area of PST, I'm considering if that is 9, the area of PQR, the full triangle, it has to be 25. Means I can say area of the quadrilateral portion, it has to be 16. So that 9 plus 16, it gives you 25. So this has to be 16. Got my point? Very simple, right? PST is to PQR, it is 9 is to 25. So PST, if I take it as 9, then SQRT, it should be coming as proportionately 60. Just need to put it in that way. Now, the answer is as such ready. I can see that now the ratio of the area of that small triangle PST is to that quadrilateral area, that is 60. It is same as they are asking you to find the area of that triangle PST, the actual area, right? So area of triangle PST divided by area of the quadrilateral, it is given as 480. The actual value I am saying. The ratio is 9 is to 60. Got my point? So the actual value, when you look at it, I can see that 9 by 60 is as good as area of triangle PST by 480. The 480 is given in the question. So this gives you the area of triangle PST. That's what it is asked. You know how much it will be? That will be 9 into 480 divided by 16. It will come. You can see that this will go 30 times. 16 threes are 48. So this will go 30 times. So 9 into 30, this will come here as 270 square units. Okay, square units. So for this question, the final answer, it will be coming here as 270 square units. Hope this explanation is clear to everyone. Let's now move on to the next question. Any doubts you have, how that 9, 16, all those things came, you have, just let me know. I shall come and explain it to you. Okay. So now let's move on to the next question. It's a very easy question. You should be getting the answer in about 30 seconds time. Over to you. Always keep a watchful eye on the timer, okay? All right. Okay, time out. So here in the question, the side of an equilateral triangle. So they have committed that it's an equilateral triangle. It is increased by 4 centimeters. If its area increases by 28 root 3 centimeters square, they have given you the unit here. Find the side of the original triangle. So let's get going. This is given to be an equilateral triangle. Okay. So let me consider the original triangle. It looks like this. Okay. Now that's equilateral triangle. You are increasing the side by 4 centimeters. So let us consider the other triangle, the one with the length increased, okay, by 4 centimeters. It looks slightly, I should say, enlarged. Okay, like this, what you can see. Okay, so that's what the second triangle it is. So I shall just write the values. Okay, so let me assume the side of that original triangle, let me say it is A units. Okay, so I can see the area of this equilateral triangle, this is root 3 by 4 A square. Agree? Now, this A, it is increased by 4 centimeters. So here the side, it will be A plus 4. This will be A plus 4. This also will be A plus 4. Because in the question, it's given the side of an equilateral triangle, it is increased by 4 centimeters. Each and every side, it is increased by 4 centimeters. That's what it means when it is set in this way. Okay, now when you do it in this manner, what is happening? The area, it increases by 28 root 3 centimeters square. So I can see now the area of this triangle, this will be root 3 by 4 into A plus 4, the whole square it will come. Okay. Now they are telling you how they are connected. This area of the smaller one, you can say that is equal to 28 root 3. My mistake, sorry. It's given that this value plus 28 root 3 will give you the area of that big triangle. Okay, I'm sorry, I put it the other way around. Root 3 by 4a square, the original area, it increases by 28 root 3. So, root 3 by 4a square plus 28 root 3, that is going to give you the new area, that is root 3 by 4 into a plus 4, the whole square. So, once you get this equation, it's just a matter of solving them and getting the value for that a. That solving part, I'm going to leave it to you. If you want a help, you let me know. I can see that here, as far as this question it is concerned, you will get the value for that A. It will come here as 12. Okay. So find the side of the original triangle. That's what it is asked here. I will get that is equal to 12. And for this question, my final answer, it will be coming as 12 centimeters. I can commit the unit here because they have told you the centimeter square in that question. So answer, it will come as 12 centimeters. Any assistance needed for finding out that value for A, do let me know. I shall definitely do it for you. Okay, it's a very easy task. You just need to expand that a plus 4 the whole square, take that root 3 by 4 inside. Root 3 by 4 a square will get cancelled off, and whatever remaining, through that you can find the value for that a. Please do that, and that brings conclusion to our question number 5. Okay, now let's go to the next question. Again, the timer will run. Make sure that you are solving the question before its time out. Over to you. Please attempt the question. Okay. So time out. So let's read the question. There is an equilateral triangle. The triangle which is inscribed inside a circle of radius 12 centimeter. So definitely we can understand that the triangle is inscribed inside the circle. It means that we are referring to that circle as the circumcircle associated with that equilateral triangle. Okay, you should understand that much by the time you have read the first 2 lines of that question. Okay, so an equilateral triangle, it is inscribed in a circle of radius 12 centimeter. That circle is inscribed in another equilateral triangle, which means that circle, it is the incircle of the bigger triangle. You should be very focused when you are reading that question. First line when you read, by the time you finish reading it, you should have understood that the circle I am considering, it is the circumcircle of the smaller triangle, and at the same time, it is the incircle of the larger equilateral triangle. Got it? You are asked to find the difference between the areas of the two triangles. Okay, it's a very interesting question, this one. Now, I shall explain this question to you. Okay, so here we go. The first thing is I'm drawing a big equilateral triangle here. Okay, let the side, I won't assume the side right now. Okay, and then I'm considering that circle. Okay, so I'm just placing the circle here. Shall place it correctly? Yeah. So this is the circle here. Just shape it. Yeah. Now I need to draw one more equilateral triangle. Okay, so let me do that for you. I'll use a different ink color. Okay, maybe. So here we go. This is one. This is the other one. And then this is the third one. You see this? Okay. So you can see that the first equilateral triangle, the red wala one. Okay, maybe I may use a black one. Okay. That will get you a better clarity here. Okay, blue one, let us go. So here we go. This is that equilateral triangle I'm referring to. Okay. So yeah, I'm ready with the diagram. See this? So that an equilateral triangle, let me say it is PQR, it is inscribed in a circle. The triangle, it is inscribed inside the circle of radius 12 centimeter. So please note it here. This radius, it is 12 centimeter. Okay. And in the same way, you can see that from the center, I will use a different ink color. Just note it. From here, this is corresponding to 12. Okay, look at this. This is 12. And I can consider that this is also equal to 12. The same circle only, right? So please note that. Now, what are the various, I should say, let me say, they are asking you to find the difference between the areas of the two triangles. That's what they are asking us to find. Okay, so how can we proceed further? This is the 12. This is the same 12 what I can consider, right? So for the triangle here, the blue wala triangle here, let me say the side, it corresponds to A units, right? So can I not say that root 3 by 4 A square area, it is equal to, for that triangle, the blue wala one, please be aware that this circle, it is the circumcircle. So area, it is equal to product of the sides by 4 times the radius. I hope you might be remembering that area of the triangle, it is given by the formula ABC divided by 4R. For a triangle, the area, it is equal to A into B into C by 4R, where R, that is the circumradius. So you can apply the same condition here, and that gets you, it is nothing but A into B into C. Instead of A into B into C, I can say it's an equilateral triangle. So A into A whole divided by 4R. That is 4 into the radius, it is equal to 12. Got my point? So with this, I can see that I can cancel the A square here. This goes off. This 4, it gets cancelled here. And that gets you A. That is the side of that smaller equilateral triangle, what you see inside, that is equal to 12 root 3. So that is your first finding here. Okay. Now let us look at the larger equilateral triangle, the bigger one. Let me say the side, it is equal to x units. So I can see that for that larger equilateral triangle, the circle what you consider there, it is the incircle. So I can see that area, it is root 3 by 4 x square. It is equal to the in radius. The in radius, it is equal to 12 r into semi-perimeter. I hope you might be remembering the formula. Area, it is equal to r into s. So I'm using that. Root 3 by 4 x square, it is equal to 12 into semi-perimeter. What is semi-perimeter? X plus x plus x, that is 3x divided by 2. So that is the semi-perimeter here. So from this, I can now see that here, 1x can be cancelled. See the simplification I'm doing. 1x, this can be cancelled. Now you can see that here, 2, we can consider that it goes here 6 times. 2 6 are 12, right? Now 6 3s are 18. I can see that here, therefore x, I can get the value here. 6 3s are 18. 18 into 4 divided by root 3 it will come. I am rationalizing it, root 3 by root 3 when I am doing it. I know that this will come here as 3. So I can see that here 6 3s are 80. So I can see that now this value will come here as 24. 6 4s are 24. 24 root 3 it will come. So the area of the two triangles can now be easily calculated, right? So they are asking us to find what is the difference between the areas of the two triangles. So we can now find out the difference when you are considering. It will be root 3 by 4 x square minus root 3 by 4 a square. That's what we are asked to find out, right? So it's very easy. The values are in front of us. Root 3 by 4, the common factor, I can take it out. 24 root 3, the whole square, minus 12 root 3, the whole square. I need to just calculate this value only, right? 12 root 3, the whole square. So upon further simplification, when you are calculating it, the difference between the two, you know how much it will come. This will come here as 324 root 3. We can see that here, everything it is given in centimeters. So you can take this as centimeters square. Okay, so just a matter of simplifying that, root 3 by 4 into 24 root 3 the whole square minus 12 root 3 the whole square. So when you do that, you can see the answer will come here as 324 root 3 centimeters square. Okay. So the first and foremost, the main understanding that you have to have here is the circle that you are considering. It is serving as the circumcircle for one smaller equilateral triangle, and it is the incircle for the larger equilateral triangle. Okay, so connect them using the two formulae which I have written here. That is ABC by 4R. Delta is equal to R into S. Connect them and then get the value for those, I should say, the sides, and then proceed. Okay, I guess this explanation is clear to everyone. Take a note of it. Now let's go to the next question. And any doubts, please let me know. Look at this question. It's a very easy question. You can easily finish this off. Over to you. Please attempt the question. Okay, time out. So we are dealing with a parallelogram in this case, right? So let's see what all things are given here. Here it is given, find the area of the parallelogram, which has two of its sides measuring 16 and 24, and the angle between the sides, it is 30 degrees. So please understand, we have to draw a parallelogram here. So one is 24, the other it is given as 16, the other side it is given as 60. So I'm just considering the parallelogram here. Okay. Now, this smaller one, let me take this as 60. The other side, let me take this as equal to 24. You can see that the measurement of this side opposite to 60, that also will be 60. This also will be 24. Like that, it will come. you can see that the angle included in between them, this measurement, it is given as 30 degrees. So opposite angles of a parallelogram, please note they are equal in measurement. So this also will be 30 degrees. Now all you need to understand is just draw one diagonal like what you see here. Okay, just draw this diagonal. And don't you see that when you draw this diagonal, okay, you can see that this actually, I should just draw it. This splits this given parallelogram into two equal triangles, two same triangles. Don't you see that? I can call this as triangle number 1, T1. I can see that this is triangle number 2, T2, right? So let us find what is the area of this triangle T1. When two sides and an included angle, if it is given, remember the area, it is calculated as half AB sine theta. For a triangle, please note, if the two sides A and B given, the included angle theta, if it is given, area can be calculated using the formula half AB sine theta. So using that result here, I can find the area of triangle T1. I call it as triangle T1. Let me put it this way. Area of triangle T1. It will be half 16 into 24 sine 30. Sine 30, it is 1 by 2. So that will get you the result. Here you can say 24 into 4, 96 you will get. 96 unit square or square units. That's what you get here, right? So that is the area associated with this triangle here, 96 square units. Same thing gets repeated here also. This also will be 96. So adding them together, you will be getting the area of the parallelogram. So how much it will be? 96 plus 96. I can say this value, it will come here as 192 square units. And for this question, 192 square units, please note that is going to be my answer. Okay. So how is the preparation going? Are you able to follow these explanations? Any doubts you have, please call me. I shall quickly assist you. Okay. Let's now go to the next question. Your time starts now. This is a very easy question. If you know one small concept related to rhombus, you can easily finish off this question in about 30 seconds time. Please attempt. Okay, time out. In this question, you are asked to find the perimeter and the area of a rhombus. The diagonals, they measure 16 and 30 centimeters. See, area of the rhombus, when the diagonal measurements are given, you can finish it very easily. Remember, when the two diagonals are given, the area of the given rhombus, that will be equal to half d1 into d2. In this case, it will be half 16 into 30. And you can say that is nothing but 16 into 15. And how much this comes to? I can see that the area, it will be coming here as 16 into 15. How much it comes to? I can say the value will come here as 240. It's given in centimeters, right? So it will be 240 centimeters square. Easy to find out. Just do half d1, d2. Okay. Now, for solving the second part, you have to understand a small concept related to the rhombus. The four sides of this given rhombus, they will be equal in length. The four sides equal in length. Now, let us consider this is the longer diagonal and let us consider this is the shorter diagonal. Got it? Now, please note the diagonals of the rhombus, they have got a property. They cut each other at 90 degrees and also they bisect each other. So this measurement, it is 16 when I can say this will be 8 and this will be 8. In the same way, 30, if I say, I can say this will be 15 and this also will be 15. You got it? So I can see that there is a right angle triangle here with one side 15, the other side 8. You can see that the side of that rhombus, it is going to be the hypotenuse over them. And I can see that here 3, 4, 5, it is a Pythagorean triplet. I am just multiplying here this value 8 and 15, right? So 8 and 15 when it comes, we have to calculate it. Okay, so we can consider the side here. My mistake. We can consider the side here. 15 and 8, they are given. So I can consider this side. You can consider that it will be equal to, we can consider like something like 15, 8, right? So the third side, let me say this is equal to A. Can I not say that A square, it is equal to 15 square plus 8 square? And I can say that is equal to 225 plus 64. And that comes here as 289. A square, it comes as 289. So that gets me A, it is equal to 17 I am getting, right? So I can see that now the four sides, they are 17 units each, 17 centimeters each. So that gets me the perimeter, how much it will be equal to. That is equal to 4 into 17, right? So that will be coming here as 68 centimeters. So I can consider, therefore, A, it is equal to 70. Perimeter, okay, that will be coming here as 4A, 4 into 70. I can say that value, it will be coming here as 68 centimeters. Got it. So they were asking you to find the perimeter and the area of the rhombus. The perimeter I have identified, it is 68 centimeters. The area I have calculated, it comes here as 240 centimeter square. These are the respective answers. Okay. So I think we can now move on to the ninth question. Look at this question. Keep a watchful eye on the timer. Okay, time out. So here you read the question, the perimeter of a rectangle is equal to that of a square. So you are dealing with two geometrical figures here, a rectangle and a square. One of the dimensions of the rectangle, I don't know whether it is the length or the breadth, and the side of the square, they are in the ratio 5:6. You are asked to find the ratio of the areas of the rectangle and the square. So let me draw the picture here. This is the rectangle under consideration. And let me consider this is the square under consideration. Okay, fine. So in the question, it is very clearly given. I don't know what is the length of the rectangle, breadth of the rectangle. I don't know right now what is the side of the square and all. So I am going to consider here one of the dimensions that told you like that, one of the dimensions of the rectangle and the side of the square, it is in the ratio 5 is to 6. So I am assuming the square, the side measurement, I am considering that it is equal to 6x. Got it? So the perimeter of the square, that is coming here as 6x plus 6x plus 6x plus 6x, that is equal to 24x. That is the perimeter of the square. They say that perimeter of the rectangle, it is equal to that of the square. Okay, so I have found out the perimeter of the square, it is equal to 24x. How did I get 24x? Because I can see that this 6 in the ratio, it is corresponding to the side of the square. So I am assuming the side of the square to be 6x. So the side of the rectangle, one of the sides of that rectangle, I can consider that it is equal to 5x. Got it. I don't know what is the measurement of the other side. Let me say that value, it is equal to P. So what is the perimeter of this rectangle? Perimeter of the rectangle is 2 into P plus 5x. That is equal to 2P plus 10x. I'm just taking that 2 inside, 2P plus 10x. This perimeter of the rectangle, it is given that it is equal to perimeter of the square. So 2P plus 10x, the perimeter of the rectangle, what you can see there, you can say that is equal to 24x. So that gets you 2P, it is equal to 14x, and that gets me P, it is equal to 7x. So I have identified the other side of the rectangle, that is equal to 7x. Okay, so the P value I just now found out, I can say that is equal to 7x. Now see, the perimeter of the rectangle, 2 into 12x, 24x is equal to the perimeter of the square, that is also 24x. You can see that the ratio of one of the sides of the rectangle, 5x, and that of the square, 6x, they maintain that 5 is to 6 ratio. All the conditions are satisfied. So can you now tell me what is the area of the rectangle? I call it as area 1. Length into breadth, 7x into 5x, that is equal to 35x square. That's the area of the rectangle. What about the area of the square? I call it as area 2. That is 6x into 6x, that is 36x square. They are asking us to find the ratio of these two areas, how much it will come. I can say my answer, it will come here as 35 is to 36. Got it? So that is going to be my final answer for this question. The ratio of the areas of the rectangle and the square. You have to be very careful there. If they have mentioned square and the rectangle, if they had told you, then the answer would have been 36 is to 35. Here it is 35 is to 36. That is going to be the answer. Okay. Now let's move on to the next question. Take a look at this. Time starts now. Very interesting question, this one. Okay, time out. In the question, it is given ABCD. It is a trapezium in which AB is parallel to CD. AB is 12, BC is 26, CD is 40, and DA, it is 30 centimeters each. Find the area of the trapezium. So if I'm just roughly drawing the picture here, this is the trapezium under consideration. Okay. So for a trapezium, AB, CD, the four sides I'm considering. It is given that AB is parallel to CD. So I shall just note it here. AB, it is parallel to CD. Let me say AB, it is equal to A units. CD, it is equal to B units. The distance between the two parallel sides, AB and CD, let me say that is equal to H. So if you know these details, then note the area of the trapezium. It is given by the formula 1 by 2H A plus B. So this is what you must know for answering this question. 1 by 2 H A plus B. Okay. So make a note of that. Now let us attempt the question. I'm just clearing the diagrams here. Let's start with the question again. Okay. So we are considering here, it's a trapezium. I'm considering this AB. It is parallel to CD. So see the way I'm drawing the diagram. Okay, this is AB. It is parallel to CD. Okay, and just connecting it in this way. Let me mark those vertices here. A, B, C, and D. It is given that AB, it is 12. BC, it is given as 26. CD, it is given as 40. And DA, this is given as 30. Okay. Now, what I am going to do here is a couple of small quick constructions I am going to make. I'm going to draw something from A towards CD, from B towards this CD. Okay. So that is nothing but the height, right? That A, let me say that it touches the point here at this P. Okay. It touches the point here, let me say at this point Q. So can you now consider AP, BQ, they will be equal in measurement because I'm dropping it perpendicular here. I'm dropping it as a perpendicular from A. I'm dropping it as a perpendicular from B to that CD. So AP and BQ, what you see there, can I not call it as the height there, H? Yes or no? So that helps me to find out PQ. What is PQ? You can see that since AB, it is equal to 12. Observe it closely. Since AB, it is equal to 12. Can I not consider that PQ? It will also be equal to 12. So I am just writing it here. PQ, let this be, it will also be equal to 12. So if I consider that QC, it is equal to X. Be very mindful here. If QC, it is equal to X, this PD, this will be 28 minus X. Because that 28 minus X plus 12, that is going to give you 40 plus 40 minus X, I mean. Okay, please observe, I'll just show you. This 28 minus X plus 12, it will give you 40 minus X plus X. It will give you CD, it is equal to 40. So if you can transpose that AB straight to PQ, I can say PQ will be equal to 12, as you can see. Then now let me say QC, it is equal to X. Then PD, it has to be 28 minus X. Now it is very easy. Okay, I just need to find out what is that value for that H. Because I know 12 is there, I know 40 is there. So I very well know that area of this trapezium, it is nothing but 1 by 2 H 12 plus 40. That is equal to 1 by 2 H 52. So I just to need to find out what is the value of the 26 into H. You got my point? 26 into H. That's what I need to calculate. So for that, I need to get the value for that H. Please observe the trapezium, it is 1 by 2 H A plus B. That is 12 plus 40. So that is nothing but 26H. That's what I actually need to find out. Got it? So for that, H I want to get. So how am I going to do that? It's very easy. Please observe 28 minus X the whole square plus H square it is equal to 30 square. In the same way, can I not say that h square from this? Can I not say that h square it is equal to 30 square minus 28 minus x the whole square? Can I not say that? Now look at the triangle which is on the right hand side over there, the right angle triangle at the right hand side over there. I can see that here x square plus h square it is equal to 26 square, Pythagoras theorem. So will that not fetch us x square it is equal to 26 square minus x square? Will I not get it that way? Now please observe, it's very interesting to see here. This is equal to h square, right? And the same thing is coming here, h square. It's the same h I am talking about, yes or no? So that helps me to connect this 30 square minus 28 minus x the whole square, 26 square minus x square. I can connect them. Got it? And that will get me the value associated with that x. And once I get the value for x, I can easily find out what is that value associated with that h. You got it? So that way when I am doing it, I can now see the value for that h. You know how much it will be equal to? You can see that here, the h value, it will be coming here as 24. Okay, I'm asking you to simplify this. Okay, because of time constraint, I am asking you to do it. I can see the h value, it will come here as 24. Got it? Now, the moment you get that h it is equal to 24, area you can easily find out, area of the trapezium. I've already said this 26 into h. So it is basically 26 into 24 you have to do. And the area of the trapezium, you know, this will come here as 624. Since everything is given in centimeters, I can say centimeter square. That is going to be my final answer. So the approach is, when the sides are given, just convert everything, transpose this 12 down, take this as x, this will come as 28 minus x, equate it in terms of h square, get the value for x, get the value for h, and then apply that 1 by 2h a plus b. This much you have to do. And of course, this question will take slightly a little extra time, but still it's worth doing. Okay, now let's go to the last question in this module. The final one, an easy one. Take a look at this question. Please keep a watchful eye on the timer. Okay, time out. I can attempt the question in two different ways. Both the methods I shall explain. Okay, so first I shall draw the cyclic quadrilateral here. Okay, so the lengths of the sides of the cyclic quadrilateral are 14, 48, 30, and 40. That's what it is given. So let me mark the points here. Let me say this is P, this is Q. Let me say this is R, and let me consider that this is S. Okay, I'm just randomly putting the points. I may not be drawing the diagram true to the scale and all. Okay, so let's consider this. But if you are drawing it somewhat true to the scale, then you can definitely visualize something scale. So 14, okay, this 14, 48, 30, and 40, that is what it is given. So let me consider that this is 40. This is not drawn true to the scale. Okay, so I'll just take the caveat here. Not drawn to the scale. To the scale. Okay, so 14 we have. The next side you can consider this is equal to 48. Okay, the third one, let this go for 30 and let this go for 40. Okay, so please note, you can consider here like this 40, 48, 30, 40. Correct? Now, if you observe, it's a cyclic quadrilateral. The four sides, it's given. Then area of the cyclic quadrilateral using the formula, you can consider this is equal to root of S minus A into S minus B into S minus C into S minus D, where S, it is equal to A plus B plus C plus D whole divided by 2, the semi-perimeter. Okay, so using this result, you know that here A, it is equal to 40, B, it is equal to 48, C, it is equal to 30, and D, it is equal to 40. Substitute the values here in this formula. That will fetch you the answer. The area, it will come here as 936 centimeters, right? So centimeter square. This way, calculation and simplification, I'm asking you to please do it. I can see the answer will be 936 centimeters square. This is one way we can attempt the question using the hero's formula. But if you have drawn the diagram somewhat true to the scale, okay, I can see that now this as such, it will be looking like a right angled triangle. Look at this. Okay, I can consider that here. This is, I'm drawing the diagram, I'm drawing the diagonal S cube. Okay, then you can see that here, this is 30, this is 40. I can see that S cube, 30, 40, this will come here as 50. Yes or no? 30 square plus 40 square, it is equal to 50 square. Okay, in the same way, can't you see that here, this also will be 90. Like that, you can say 48 square plus 14 square when you do. You can say that will be coming here as 50 square. Look at this. 48 square, that is equal to 2304 plus 14 square, that is 196 when you do. You can say that comes here as 50 square. Okay, if you're able to make it out quickly, then you can see that it is actually made up of this particular cyclic quadrilateral. It is actually made up of two, I should say, right angled triangles. So I can find out the area of this triangle T1, the area of this triangle T2, add them together, you can get the result. So this can also be done in this fashion. That is 1 by 2, 48 into 40 plus 1 by 2, 30 into 40. When you add them together, that is half BH, right? You still get the same value, 936 centimeters. But for that, you should understand when you're drawing the diagram true to the scale, this will come to picture. But if you don't remember this, or if you can just consider that this formula, it is somewhat more handy, then you can use this also. So both the methods are available. All right. So with this, let's conclude today's session. I hope that you had a good practice today attempting these questions. All right. So a couple of quick concluding notes. I hope that you are able to get enough time to think. Although you may not be able to answer the question within the stipulated time for all the questions, but still, I hope that you understood how to read the question and also the concepts that has been explained. You may please share your valuable thoughts and comments in the feedback form, what I will be sharing with you. And also, last but not the least, please subscribe and share details about my channel amongst your friends. Okay, so with this, I will conclude this session. Thank you very much and take care. You have reached the end of this session. Best wishes.